Hi, the goal of this lesson is to teach you how to solve basic multiple step equations. To do this, you must absolutely know order of operations and how to solve one-step equations. Okay. So specifically, the goal is to solve equations that look like these. And solving all of these is actually very easy. All you really need to know, again, is order of operations and one other main idea. Okay. But let's first review solving. Okay. What does it mean to solve an equation? What that means is we must get the variable by itself. Okay. How do we do that? We do that by undoing the operations that are being done to the variable. And there's an asterisk here because there are some equations that can't be solved this way. We have to use other techniques like factoring. But for today's equations, this always works. Okay. Now, how do we undo each operation? Well, we do its inverse or its opposite. Okay. So for example, solving means here getting x by itself. To get x by itself, we have to undo a times 3. How do we undo a times 3? We divide by 3. Okay. To get n by itself, we have to undo a minus 7. So we add 7 on both sides. Now, the question here is, when there's more than one operation, what do we do? And before, there was only one operation, so it's pretty clear. We only had one thing to do. Now, what do you do? Now, let's consider a few problems, and the process should be clear. So here I'm thinking of a specific number. Okay? And the first thing I'm doing to this number is I'm multiplying by 3. The second thing I'm doing is I'm adding 2. Okay? If the result is 17, right, what is the original number? Okay? Now for most people, even if they haven't studied algebra or know anything about equations, right, it's just kind of clear that you just work backwards. Whatever you did last, you undo that first. Right? So let's do that. Right, we're going to undo each step in the reverse order. So we know that the last step was plus 2. So how do we undo plus 2? Well, we subtract 2, the inverse. Okay? We do that, we bring this down, this cancels by design. Right, now we have a one-step equation, which you should know how to solve, and we have an answer. Okay, again, how do we undo a times 3? We divide by 3. Now let's do the same process for this problem. Okay? So I'm thinking of a specific number. The first thing I'm doing is adding 4. The next operation I'm doing is multiplying by 5. Okay? If the result is 30, right, what's that original number? Again, let's undo each operation in the reverse order. So we're starting with the last operation done to n. Right? So how do I undo that times 5? I divide by 5. This cancels, bring it down. One-step equation. How do I undo a plus 4, minus 4? Another example, I'm thinking of a number. Okay? The first operation I'm doing is I'm subtracting 3. The next operation I'm doing is dividing by 2. If the result is 6, what is that original number? Well, if dividing by 2 is the last operation being done to x, we undo that first. How do we undo dividing by 2? We multiply by 2 on both sides. Okay, so we do that, bring it down. How do we undo a minus 3? Plus 3 on both sides. Okay. Another example, I'm thinking of a specific number. The first thing I'm doing is dividing by 2. The next thing is I'm subtracting 4. Okay. If the result is 21, what is that number? Okay. So subtracting 4 is the last operation being done to n, so we undo that first. Okay. Plus 4 on both sides, bring it down. How do we undo dividing by 2? Multiply by 2. Okay. Now, for most people, solving these type of problems are pretty straightforward. In everyday life, there are situations where when we want to get things the way they were originally, we just undo each step in the reverse order. So these were easy because I explicitly told you, this is happening first and this is happening second. And once we knew that, working backwards, that was also very straightforward. Now, in contrast, you may look at this and not know how to do it, right? What's the difference? Well, here, it's not clear at first. It's not clear, right? The variable. Okay. So the point is, to solve these equations, you really must understand order of operations, okay? And therefore you must practice order of operations to be good at solving. Okay. Now, how exactly do you practice order of operations? Okay. By substituting and simplifying. Okay, so for example, if I want to practice solving an equation like this, okay, I practice substituting and simplifying into this expression. Okay, for example, when x equals 6, what does this expression equal? Well, 6 minus 5 times 3. The point is, I'm practicing minus 5 first, times 3 last. So when I look at an equation like this, I just automatically know that times 3 is the last operation happening to x. And therefore, to solve this, the first operation I do is dividing by 3 on both sides. So the point is, we just practice this a bunch of times over time. So we just know automatically what the last operation is. Okay, so in this case, how do we practice solving this type of equation? The same idea. We practice substituting and simplifying into this expression. So we say, oh, when f is 5, well, what are we doing? Okay, but this may be a bit too difficult, which is okay. So what do? Well, first we start with just 2 steps. We start with just this right here, times 6 first, minus 3 next. Okay, once we become good at 2-step equations, we add a 3rd step, right? Times 6 first, minus 3 next, and divide by 3 last. Once we become good at 3-step equations, we move on to a 4th step. Okay? And once we become good at that, we just see this and we automatically know this is an equation, right? If plus 4 is the last step being done to f, right? Minus 4 is the first step to solve. Okay. This is also very important when you check your answer, knowing how to substitute and simplify. So let's say, for example, that we think the answer is 5. How do we check? Substitute and simplify. We substitute or replace x for 5. And we, again, according to order of operations, we simplify. Times 3 first, plus 4 next. In this case, we get a true statement, and so we know that 5 is the answer. Okay. In summary, what do you need to know to solve these types of equations, these basic equations? Okay. 2 things. Order of operations, okay, and its idea of working backwards, of undoing each operation in the reverse order. Okay. So this exactly is the procedure. Okay. You undo the operation done last in the variable, and you repeat until the variable is by itself. And I'm teaching it this way because it's really most important for you to know the first step. As you solve, the equation gets simpler and simpler and easier to solve. Oftentimes students look at equations and they have no idea how to start. So it's really important to focus on the first step, knowing how to start. Okay? So now let's practice. Okay? And it's much more effective practice if you first think of the answer on your own and then check your answer. So I will go through this a bit fast. So pause the video while you think, if needed. Okay? Again, what's happening to x here? Well, first, we're multiplying by 3. And last, we're adding 5. So how do we undo adding 5? We subtract 5. Okay. What's happening to n here? Again, based on order of operations, minus 2 first, times 4 last. How do we undo a times 4? Divide by 4. Okay. You may be thinking, well, couldn't I also distribute the 4? That's true. We could do 4 times n is 4n minus 8. That works. However, in this case, if we're doing it all in our heads, it's much easier to divide first and not have to distribute. But for the record, either way is fine. Okay. Here, what's happening to C? First, minus 3, and last, divide by 2. So how do we undo dividing by 2? Multiplying by 2. Okay. What's happening to B here? First, divide by 3. Second, subtract 5.